So welcome, everybody. We are very pleased and very honored to welcome for this last session, Corinne Le Quéré. Corinne is a professor of climate change science at the University of East Anglia. She is also very well known in France as a president of the Haut Conseil pour le Climat. Corinne is also a member of the UK Committee on Climate Change. The keynote today is about the interactions between land use and climate. Corinne, the floor is yours.
Thank you very much. Hello, everyone. Bonjour à tous et à toutes. I'm really pleased to have the chance to speak with you today. I'm going to speak as an academic today. Although I chair the French High Council on Climate in France, I will say just a few words about that towards the end. My intervention today is really from a person who has worked on the carbon cycle for most of my research career. I do want to share some slides, which I will do straight away if I can just ask for your patience while I set this up. You should now see full screen. Can someone confirm?
Perfect. Yes.
Yes. Okay. Excellent. So today I want to talk about using land in the context of a changing climate, and particularly in the context of the ambition by so many countries to reach net zero emissions in a time frame of a few decades. I want to talk about the imperative for doing this, so for that objective of net zero, where we are with reaching net zero, and what are the consequences of having these objectives for what we do in academia and in society in responding to the joint challenge of climate change and biodiversity loss. The first point I'm going to make is that an active management of the biosphere at large scale is going to be essential, is already essential to achieve net zero emissions target either at the global level or at the country level. So there is no escape from managing the biosphere if we want to tackle climate change along the lines as is inscribed in the Paris Agreement. And the reasons for this lies very firmly on the science behind climate change. Warming of the climate system, which you see there, this is 1.1 degree today, is directly proportional to the cumulative amount of CO2 emissions that we put, or long-lived greenhouse gases that we put in the atmosphere, past, present, and future, so that we have a limited amount of sort of allowable carbon emissions that correspond to future levels of stabilization. So if you want to determine if you have a limit warming that society is prepared to handle, or thinks that we can manage the risks of, like keeping global warming well below 2 degrees, the main goal of the Paris Agreement, and pursuing efforts to 1.5 degrees, then that gives you the carbon budget that you have. And you then have an imperative with that carbon budget to eventually come down to what we call net zero emissions. And of course, the lower the temperature level, the quicker you need to do this stabilization at net zero. But the reason why we need net zero emissions is not only until you have net zero, until we stop completely emitting carbon dioxide and long-lived greenhouse gas to the atmosphere, do you have that stabilization of temperature that you see on the graph here on the right-hand side. And you can slowly, if you pursue with these negative emissions, with the extraction of carbon, slowly decrease, but very, very slowly decrease your temperature level. But by and large, the bulk of the warming is irreversible. Because there are activities that sustain global society that we cannot, at least today, foresee that there are going to be, that the associated greenhouse gases can be brought down to absolute zero. And that is just a limited number of activities. Agriculture is one of them, probably aviation is one of them, and some of industrial processes, not very many. Then in order to reach this net zero emissions, you need to extract CO2 from the atmosphere. So this is all the theory behind that extraction of the atmosphere, of CO2 from the atmosphere. I should say here that we're not talking about the natural carbon sink here, so the absorption, naturally the response of the biosphere and the ocean to increasing CO2. We are talking about actively extracting CO2 from the atmosphere, either from managing the biosphere, so increasing afforestation, reforestation, or from more technology-based options. So this is from the imperative of the science. We're now not on track, and this emergence of knowledge has led to this need of greenhouse gas removal. This question of how much greenhouse gas removal and how we do it, what is the share of the management of the biosphere in this, and what is the share of other methods, has received a lot of attention. I should say perhaps first that the presence of removal options in model scenarios, which you've heard about today, is an emergent property of these model simulations. So the model simulations do not per se prescribe negative emissions. What they prescribe is a market price and an option for removing carbon through different methods. And it's the request to the model, the constraint of limiting climate change to a certain level, that has led to this emergent sort of artificial market property of trading biomass, so that we could, at all costs essentially, or at least at costs that are sort of half affordable, we could actually maintain this global warming to a given level. So quite a lot has been done, and you see it from particularly the report, the special report on 1.5 degree warming that was published by the IPCC 3 years ago now, where they have explored a lot of different scenarios. And these different scenarios, essentially, you have three things to decide. The first one is, what is the warming level that you're prepared to absorb, to deal with, and that gives you your overall carbon budget. Second, how quickly you're prepared to reduce your emissions now, and that sort of facilitates your life later. Or if you delay too much, then you're stuck with the need to extract CO2 massively from the atmosphere, unless, of course, then you loosen your climate target. So greenhouse gas removal, GGR, which is here, is in practically all emission scenarios that are compatible with limiting climate change to 1.5 degree warming, and in most scenarios in lower quantities that limit climate change well below 2 degrees. So the emergence of this property from the socioeconomic models has led to several things. One is quite a reaction from carbon cycle scientists, including myself. I was among the group, one of the first ones who sort of highlighted this behavior. We published this paper in Nature Climate Change in 2013, which was quite early, that said betting on negative emission, that highlighted there was a big issue here, that model scenarios were in fact pushing the problem, or at least one of the key solutions, to later. But since then, a lot has happened. And there's essentially two categories of things that have happened. One is the exploration of the theoretical feasibility and the conditions of deployment has happened, and I will talk a little bit about that. And the second is, in fact, the planification of negative emissions in the real world. And I will also start talking about this a little bit. Before I go there, though, I do want to put things in context. I was myself quite scared when I first saw these emissions scenario, but when you look at it in the context of what is already happening to the biosphere, especially to the carbon storage in the biosphere, it's already ongoing massive, massive transformations. And this is captured perhaps in part by this slide and the next one, which is, this is the perturbation, the human perturbation, anthropogenic perturbation of the global carbon cycle. You have the world here from different dimensions at the bottom. And what we are doing now, of course, is depleting the fossil reserves of fossil fuels, putting this CO2 in the atmosphere. But we are also deforesting, managing land in a way that degrades a lot the ecosystems, but also in a way in some places that in fact rewilds the ecosystem. I will explode this box in a minute. The biosphere is responding to increasing CO2 in the atmosphere by increasing its stock because essentially higher levels of CO2 lead to more water use efficiency, so plants can grow more, and there is a biosphere enhancement from that. You have also an ocean uptake of CO2 simply from biophysical, biochemical processes where CO2 diffuses from the atmosphere to the ocean and then is transported to the deep ocean. In my discussion today, I focus completely on the land, although I'm an oceanographer by formation, and I do want to say just a few words about the ocean today. The ocean biomass is operating very differently from the terrestrial biosphere biomass, whereas in the terrestrial biosphere, you have about 500 billion tons of carbon stored in above ground biomass, below ground biomass. In the ocean, you have about 3. So it's a 500 to 3. Yet these two ecosystems have exactly the same productivity, about 50 petagrams of carbon per year, net productivity. And that is because everything gets eaten in the ocean. It's really, really rapid. The organisms live only about a week. It's always constantly grazing by different organisms, zooplankton, productivity that responds to nutrient brought up to the surface. But this very, very active ecosystem cycle is not what's causing or what's taking up anthropogenic carbon, because it is thought to be limited by nutrients that are coming from below the deep ocean. And as long as we don't substantially alter the physical circulation of the ocean, this biological pump, which on an annual basis is as big as the emissions of CO2 to the atmosphere, should continue. Now, this, as long as that I have just mentioned, is a huge research question. I myself, it's my main research topic, but and a lot of people in Paris at ENS in particular work on this. But I will go today with the assumption of what we actually know and discard changes in the marine biomass for now. I want to talk also about size. So building on to this natural carbon cycle, we've had deforestation for a long, long time. Historical deforestation has been actually relatively stable, although geographically it moved around quite a lot. We had Europe, Russia, deforest, North America, of course, then China, other Asian country. Now it's the tropics that are deforesting, but the size of the deforestation has not hugely changed. But because it's been going on for such a long time, the total amount of CO2 that has been deforested or from land use is in fact as big as the total amount of CO2 that has been put in the atmosphere from coal. So what you see here is the effect on atmospheric concentration, the stock of CO2 in the atmosphere. Pre-industrially, 1850 was 286 parts per million. Coal is responsible for plus 99 parts per million, then oil and gas for another big chunk. Then you have land use plus 98 parts per million. But then you see the offset from this regrowing biomass, which has practically entirely offset the CO2 that we've put in the atmosphere from the deforestation up to now. And then there's an ocean sink here. So essentially what we've done is deforested some land area. We've cleared lots of land. We've taken that carbon stock and put it on top of different land area elsewhere. So we're restructuring through what is happening massively, the quality, the location, the functioning of the terrestrial biosphere. We know a lot about how that happens, where that happens, what are the processes behind that. And the best demonstration of our knowledge is in this plot here, which I absolutely love, which is a mirror image. You have time here, 1900 to recent past. You have the emissions from land use change, which is land use change, and forestry, mainly at the core deforestation, relatively constant over that time period. Emissions from fossil fuels increasing very rapidly. And here at the bottom is the partitioning of these emissions among three big sinks: the atmosphere, where it causes warming of the climate system, the ocean, and the terrestrial biosphere. So the temporal changes of this, these are 5 components that are estimated almost independently from one another. You see that we can explain the total emissions here reasonably well. We can explain the change through time reasonably well, but the black line over there is the mirror image of the emissions line over here. And there's a gap between the total sinks and the actual known emissions, which reflects the uncertainty in our understanding today. So clearly, there are lots of things still to explain, but we have a first-degree picture of what is going on. So we like, as in many things, and I maybe open a little parenthesis here, that very often things are seen in this climate change debate, and biodiversity is exactly the same thing. Very often things are seen as black and white. It's a success or it's a failure. We understand everything or we understand nothing. And it's actually not like this. Most things are gray. Most things progress through time. And very often it's really about trying to anchor your knowledge into what exists so you can actually make a contribution and move forward. So what I want to do next for the last sort of slide of this section 2 here is to dig into this land, these two land bits, particularly the land use change one, the brown one here, and the green one over land. And the land use change is a fascinating one because we talk about very often land use change emissions are taken as a whole, they're taken globally. Mostly because it's really difficult in a way to estimate at the country level how much emissions, how much the sources and sinks. So the fluxes two ways on land are difficult to estimate and measure. But we're making really huge progress scientifically in trying to decipher, break this down, this land use change component into things that are more palatable. And this is here the land, this is the brown bit that I showed you on the previous slide. I'm assuming you see my mouse here. On the right-hand side, top right, we have separated this total, this net land use change into two super useful property. One is the gross emissions. So if you only look at the regions where you have deforestation and you add them up, then what do you get? And you get actually an emissions that is really big. I mean, it's 16 gigatons of CO2 per year compared to fossil emissions, which are about 36 at the moment. It's a big number. And then decompose into also the gross sinks. So this is the carbon storage in managed land. And this is also a big number. So we have a gross sink of about 11 gigaton of CO2 per year. And the reason why it matters to show this in terms of these two components instead of the total land is that we have leverages in place for both bringing down the gross emissions, so the deforestation bit to zero, and restoring, rewilding, regrowing the biosphere in the managed land at the bottom. Now, I live in the UK, and the UK is really very, very largely deforested, 88% deforested. You really see it with your own eyes, the potential for this gross sink here, if we only could manage the biomass, the biosphere, land more effectively. That's the first point I want to make on this slide. The second point is over here, is when you look at, so the land sink here is in fact the increasing carbon storage in unmanaged biosphere. And it's essentially the response of the terrestrial vegetation to increasing CO2 in the atmosphere. And when you sum them up, land use change and land sink, you see here, that's my second important point, is that the storage of carbon on land currently is growing. So not only over the whole industrialization, we're now at zero balance between the total emissions and the total sinks on land, but we're now naturally, because of this response of the ecosystems to increasing CO2 emissions, we're automatically growing the terrestrial biosphere. So, but the characteristics of this storage is very different. And hence, there is really a big role, especially on the managed land area, to ensure that the regrowth of this biomass is made with other priorities in mind, including particularly the extremely critical priority of enhancing and sustaining biodiversity. Okay, I'm slowly moving to my sort of key message here, and I'm moving on the operational side. I guess you can perhaps just sense at the moment that things are happening. There's an imperative. We have a lot of net zero emissions target. Things are happening. And I want to give you a little bit of a flavor of the scientific thinking about these carbon removals option. And the main message that will come out of this section is that all the options for increasing carbon storage require, one is a careful assessment of effectiveness, size, but also potential impacts and co-benefits. But more importantly, operational sustainability framework is so critical, is absolutely critical. I think this is the make or break tool that we need to put in place at the global level. So for exploring this section, I want to lean on a report of the Royal Society on greenhouse gas removal that was published a couple of years ago, that was led by Gideon Henderson, and I contributed to this myself. And it was a report, slightly scary report. I was a bit reluctant at the beginning. I didn't really know what to expect, because the report brought together scientists from the Royal Society, like myself, but also engineers from the Royal Academy of Engineering. And these people they're a bit scary because of their sort of big muscles. So, but we did this report with a review of the literature. We had roundtables, we had workshop, we brought experts in for expert elicitation, expert assessment. It was really super interesting in the end. And we came out with, there's a number of methods that can be used with to do carbon capture, to sort of do these negative emissions. And in our assessment, we reviewed the feasibility, including the availability of land, considering the other uses of land that land is needed for, the timing, when are things going to be ready, the size of the potential, the location, the permanence, the cost, the market mechanism. And we did ask, as well, as I was saying, experts for their assessment. And what came out of this is a number of options. And the options, you have to remember that there's two processes involved here. One, you need to remove the CO2, but the second, which is often forgotten, in fact, is that you also need to store that carbon that you have removed in a long-term storage. And if I start with the storing bit, there's the geological reservoirs, there's the built environment, so furniture, walls, buildings, and so on. There's the land storage, either above ground biomass or soils, and there's the ocean storage. And in doing this assessment, we discarded two options that are often brought to the table. One is the fertilization option of the ocean, because there's too much uncertainty in the impacts on ecosystem and in the permanence of it, because as soon as you stop the fertilization, then the CO2, at least part of it, goes back to the atmosphere. And the other one was, two more were really highly uncertain. Ocean alkalinity, again, an ocean element, in part also because of public acceptability difficulty. People don't like to touch the ocean. We love the ocean, it's great. And the other one was concrete because of the storage, permanence of the storage. But the biomass ones, the ones in green, were the ones that were, in fact, the most appealing for a variety of things, including the simple ones like reforestation, because they had multiple benefits. Of course, we love reforestation, but there were also, we know how to actively manage the land in agriculture, for example, to improve carbon in storage in soils, and so on. So there was a bunch of appealing ones here in the middle, but all in all, they were not very large in terms of potential compared to the need. And the big ones, they're really the two to the left. The first one, direct air capture, and I think previous speakers have mentioned the cost of this, which is a difficulty. And the second one is the bioenergy with carbon capture and storage, which is really the one that has the most potential at low cost. And I don't want to talk for or against this option. I just want to provide some information about where we're at with this. And very often I've heard misconceptions that these options don't exist and they're options for the future and everything, and they're speculative and so on. And to some extent that's true, but to some extent it's also not really true because carbon capture and storage does exist, not permanently, but it is used in industry to pump CO2 out of the underground storage where it is actually. And bioenergy is also used. The big questions, of course, are the ones that were discussed today about the feasibility of this and about the implications for the bioenergy, for the biodiversity. But I want to jump straight away to the assessment overall before going to the rest of my presentation. We did both an assessment for the world and an assessment for the UK. And here I present the UK scenario, which showed a few interesting things. The ones that are ready for deployment are relatively small, not that small, but smallish. So if you assess that 130 megatons of CO2 per year is maybe a bit high in terms of the needs, I'll come to that in a minute. But definitely you do about a third with the ones that are ready to deploy: reforestation, habitat restoration, soil carbon sequestration, and buildings with biomass, which is tiny but useful. The ones that are really big scale, they require carbon capture and storage. They're not ready. And the ones that are not yet demonstrated at scale, where they're biochars and enhanced terrestrial weathering. And if we're going to do this, if we're going to need this, and it certainly looks like we will and we do, you have to do this properly. And this is where I think we so much need our intellectual efforts in academia to accompany these planned changes. Recommendations that we did in this report is all about trying to do this properly. And so number one, continue and increase global efforts to reduce emissions. Of course, negative emissions are not instead of all you can do to reduce emissions. They're for the last little bit in the end. And implement, look at multiple different options, build a carbon capture infrastructure, incentivize the demonstrator, put the bucket mechanism there, establish a framework for global sustainability. And this one, number 6, is crucial. It's absolutely crucial. Build GDR in regulatory frameworks and in trading system. At the moment, they are not. And establish, of course, the science-based targets for that. Okay, I'm going to continue with a few minutes, if I may. Anyway, I can't see the chair now, so I'll just assume it's okay. There's 2 more things I want to say. The first one is the national countries that have plans for net zero, and they have plans in place. Those that don't have just the target, but they have the plans, they count on this. So they count on heavy use of biomass-related options being available. I want to show you 2 examples of 2 countries that are relatively well advanced in their plan. The left one is from the UK Climate Change Committee. And if you, let's focus, let's just do the right bar here. So this is the structure of, this is what emissions is going to look like in a net zero world in 2050. And above the line, you have all the bits that are incompressible, the emissions that are incompressible: agriculture, aviation, and a little bit of industry. And below the line is the where the negative emissions will come from, and the soft ones like land use, afforestation, soil carbon storage, they're in this green one, they're about a third, and the hard one like biomass with carbon capture and storage, they're the big ones. In France, similar picture in terms of size. So in the UK is about 90 megatons of CO2 per year. France is about 80. So they came completely independently to a similar conclusion that the incompressible emissions from agriculture, from some of the industry is there, and we'll need to offset that. And in France, again, very similar picture. Forests is about a third, and the rest is the storage that is a little bit more active, with this BECCS being about 10, 12 megatons of CO2. These are two countries of the same size, same emissions today, more or less. So all this to say that the size, all this to say that planning is really on the way. Planning, countries count on this, they plan for this. If they don't happen later, we have a problem unless we're able to accelerate and to offset more of the emissions, which is in fact a possibility. In the UK, where the Climate Change Committee has several scenarios, then the size of this negative emissions need is directly proportional with what we're able to do in terms of reducing emissions, unless the UK decides to open up a market and sell their credits to countries where they don't have this possibility. So the market-based options are extremely important, and hence the reason why one of the discussion points in Glasgow is this Article 6 with the rules for market-based become really quite important here, although I'm not so knowledgeable in that space. I'm just anticipating questions here. Last point here on this country base is that in the UK, where there is also evolution for a range of scenario, you see that things start to be in place in 2025, 2026, 7, and size in these removals is really needs to ramp up by 2030. So there's not a lot of years for the actions for us now is to help make this happen in the most reasonable, best possible way, given our priorities for climate change, but also our other priorities. And very last comment, and I want to now just get my head back above the water, go out of this land management and storage, and take a more overall picture of how we respond to climate change in a way that respects also our other priorities and in a peaceful way. And I want to talk about two other dimensions, adaptation measures, but also the just transition, which was touched upon also in the previous section. We focus, I'm going to put this up here, a composite picture that I've put together. On the left-hand side, you have, the bubbling need, the voice of the youth, the voice of all kinds of people who rise up to the challenge and say, we need to tackle climate change. Climate change is a little bit addictive, I have to say. I mean, those of us who've been in this world for a long time, it just becomes an obsession for a lot of people. But when you think about it, it's creating an environment that is really getting quite tense, quite risky. So you have the bubbling up of the youth on the left-hand side, but implementation of actions have already created some pretty dramatic social responses, like in France, the protests of the yellow jacket that was triggered by the rise in carbon tax. In Ecuador, they removed fuel subsidies and all the poor people went in the street because these subsidies are subsidies, social subsidies. In the Netherlands was a different protest. They said, well, the farmers are blamed for climate change, it's not our fault. And they went in the street to protest for that. And Extinction Rebellion in London came to a clash, complete face-on-face with people who were just trying to go to work, with very, very ugly dimension to this confrontation. Just how, in that context, how are we going to succeed to do rapid decarbonization, rapid transformation, positive transformation of the biomass, keep the biodiversity there, keep social justice on the table? And I think that this can only be done by bringing other dimension, caring for people in society through adaptation discussions as an entry point to say we need to do something, bring in constantly the elements of just transition so that it's not about tackling climate change for tackling climate change, but it's about creating a better world for all the generations of tomorrow. Thank you very much.
Well, thank you. Thank you, Corinne, for this very clear, important, and interesting presentation. Now we have a few minutes for questions. So question from the room and question also from the chat. Please ask for the mic. And
Hi, Corinne. Thank you for your very interesting presentation. My question would be, when we hear about CO2 concentration, to what extent is this concentration heterogeneous through the atmosphere? And if it is indeed heterogeneous, then you have like special issues to implement carbon sink or carbon removal. So how do you tackle these issues, and is your report accounting for this?
Yeah, thank you for the question. So the CO2 concentration is in fact quite homogeneous, and that's why we have so it doesn't matter where the cuts and emissions come from, because we're all feeding into the same atmosphere. So within a year, the atmosphere is completely well mixed. And so the long-lived greenhouse gases like CO2 stay in the atmosphere very long. So they are really completely well mixed. But you're completely right that when you think about the location of the storage, then you have to really be careful what you do, because not all the locations will be equally efficient. Some locations might have a more or less positive effect on the albedo, so the color of the earth, with more or less effective climate mitigation, and also other regional and local effect. But by and large, is really mostly about where it makes sense to store back this carbon, where the land is available, and it doesn't compete with other uses of land, at least in a way that cannot be managed.
Thank you so much for your excellent presentation, and your work is really, really incredible. So I was wondering, it seems to me there's a little tension between a couple of things you said. So at one point you said, in Britain, there's a large amount of deforestation, and it would be really wonderful for mitigation efforts if there was more afforestation. But then at the end, of course, you said that we have a very short time period, and it seems that the question of temporal scale might be hard to adjudicate with respect to afforestation. Aren't the time scales too long? My guess is that it's part of an all hands on deck. We should try to pursue as many different kinds of mitigation as possible. Some of them might work in the short term, some of them might work in the longer term. But it seems that those two things in particular might be hard to hold simultaneously. Thanks.
Yeah, I mean, we're stuck on time scale, because in terms of removal, the timescales are long anyway. I mean, there is no technology that is today ready except for afforestation, which has timescale of a growing tree. On the other hand, the effect on CO2 is real. from the beginning of the afforestation to the full maturity of the growth forest, of the grown forest. I do want to jump on your question to make one point that I haven't actually made yet, which is that one of the main element that is coming out of this management of the environment is that in order to get a continuous permanent carbon sink, you actually have to positively manage your forest. So it's not about planting your forest and you leaving it there, because if you do that, then your carbon sink saturates, your forest reaches maturity, and that's the end of your carbon sink, of your additional carbon sink, I should say. But you can, with good practice, harvest part of your forest in a way that enhances continuous growth of your forest through time, or not continuous growth of the forest, but continuous growth of the biomass material, which then you have harvested and you can store somewhere else. So it does give you, generating this sustainable management of the biomass and of the forest in particular, does give you the capacity to have an enhanced carbon sink in the long term.
Thank you. Well, we have a question from Robert Sokolov, I think. Robert?
Yeah, I'm a little bit scared by that, actually.
I actually wasn't raising up my hand, but I was thinking about what I would ask, and I don't know why I'm scary. But nice to meet you, Corinne.
Nice to meet you.
I'm thinking about Drax. In your country right now, wood chips are being brought from the US Southeast forests and put in a power plant with CO2 capture. At least I think that's the concept. And there's all kinds of debate about whether it's a decent project or not, from the point of view of carbon, first of all, and ecosystem and biodiversity second, I suppose. I don't know as much about it as I would like. What lessons are there from that project?
Oh yeah, thanks.
It's a very large project. It's one of our best early examples of a real project. And I hear terrible things about it as well as good ones.
Yeah, thanks for your question. I mean, that's an extremely good example. So Drax was a coal power plant. It's been converted to biomass. It imports parts of its chips. I think about a third of its biomass, but I'm a little unsure, from the eastern United States. And they have, so because it is such a hot topic, also in the UK, they have very, very stringent sustainability criteria for that biomass. And allegedly, and there's no reason to believe that it is not correct, the management of the biomass in the forest that provide the pellets to Drax are measuring an increased carbon storage in these forests, so that the import, so that the market mechanism is leading to more bigger forests because of the demand for pellets. Now, where there is an issue, I think is not so much the direct effect of the market mechanism, but it's the indirect effect, which is that if you have very high sustainability standard, you get the best sustainable wood pellets that are generated. And unless you have a very high sustainability standard of the whole country, then what happens is your best sustainable pellets go to the country or the place for the highest standard, and the rest hasn't got sustainability standard. So the problem is, does building this market generate more sustainability overall, or does it just displace the sustainable pellets to the biggest demand and doesn't actually change your overall sustainability standard? And that's why I was putting the emphasis on my presentation that the overall sustainability standard, both at the national and the international level, are absolutely determinant. And so just one more element perhaps to this, because we've studied actually this Drax example quite a lot. And the UK, the Climate Change Committee, in its biomass assessment of the biomass use, has an assessment of the sustainability of that biomass. And in fact, it does two things. One is that it only imports about a third of its biomass needs with the intention that, or the thinking that it will be easier to have sustainable biomass locally. And the second one is it has an assumption about what is the UK's fair use of sustainable biomass. And you get, in fact, zero sustainable biomass unless you have a global framework. But the need for developing a global framework is absolutely flagrant.
Wonderful, wonderful answer. And I'm listening as an American who is essentially having good environmental behavior rewarded from another country. I mean, it's like having logging.
Yeah.
As we would logging where we might be looking at Indonesia. Brazil, Britain is looking at the US the way we normally look at Indonesia. And you are saying that you are imposing strong environmental standards on the American forestry sector.
That's right.
Thank you. Katie?
Thank you for your nice presentation. One of the interesting figures you were showing was about the different carbon sinks on land. And I was wondering, there must be a trade-off between how perennial they are and the actual potential volume they can capture. And I was wondering, when you do the assessment for the UK, for instance, how you trade those off. Because you show that the role of habitat restoration, for instance, buildings with biomass had a very small share of the scenario for the UK. And is that a normative conclusion, or should we actually aim to enlarge it? Or, yeah, with respect to these different criteria, if we care more about the risk of it not being perennially stocked or stored, which options should we rather aim for? Thank you.
The quantity is more controlled by how much construction there is going on in the UK at the moment. So there is not, I mean, the UK is just already super dense. So there's not that much construction in the UK at the moment. And the longevity of the wood in construction products is not the limiting factor, but more like the demand for construction product. I'm not familiar enough with the details of this specific analysis to answer a little bit more ecologically, let's say, about the longevity, I'm afraid.
Thank you. I think that we have a question from Mr. Kane, no? She left, maybe. Yes. Robert Sokolov, you have another question? Oh, Simon Kane, sorry. Simon Kane, please, the floor is yours.
Thank you very much for the very illuminating talk. I just had a clarificatory question, because when you talked about BECCS, I thought you expressed some frustration with a common discourse about it that was skeptical about whether it could be upscaled. But I wasn't quite sure what your final position was. So I understood it to be, look, this happens already. We know how to do it. But do you think then it could be expanded considerably and the upscaling isn't an issue? I wasn't quite sure where you stood in the end.
I have a nuanced view. I think BECCS is in risks of backlash from an ideological perspective, particularly that it includes bioenergy, which doesn't appeal to lots of society. I think it's a potential solution. It is certainly potential, and I would say feasible at the UK level, because of the storage capacity and because of because essentially we have in the UK has a big fossil industry, a big gas industry, lots of pipes under the North Sea, lots of infrastructure, lots of know-how that you can, and these people are going to, run out of a job in a way. So you can actually rechannel this. There's a lot of thinking. We have DRACs. There's been some experimental study. So I think it's certainly worth serious investments. In the same way that hydrogen is receiving lots of investment at the moment, I would put them in the same category. Whether it delivers, you have to demonstrate that. And I think that we don't know yet whether it delivers at the large scale. It would certainly deliver something that is substantial, at least for a country like the UK. Globally, globally, I think there's some big questions to be answered. The main one is the sustainability of the biomass, but these questions can only be answered by doing large-scale trials.
Thank you. Could I ask a quick follow-up? I mean, assuming I can, you said there was, so it seems like it's technically possible, but politically it might be challenging. But I'm asking out of a position of ignorance, so this isn't a trick question, but what aspects of bioenergy is there pushback against? Why do people resist bioenergy?
There's a lot of pushback from especially green NGOs that don't want to see the use of biomass in this way. There's some pushback because of the competition for land and the very real potential that it pushes prices up for food production. So you can do it badly, actually, essentially. To do it well is tough.
Okay, no, that makes perfect sense. Thank you. Thank you very much.
Hello. Yeah, hello. Yes. Congratulations for your clear presentation and to highlight the potential of these removal techniques. You stressed the role of the students here, that through their knowledge and their brain will help us find the nicest solution for the future. I would like to ask you about what is your vision on the role of the private sector in that, and in particular considering the potential problems arising from rediscussion on Article 6 of the Paris Agreement that will happen in Glasgow in a few moments.
I mean, the private sector has a really big role in tackling climate change. They have investment, infrastructure, know-how, they have money, they have a big place in society. And so I think that their energies need to be channeled, but they're only going to do this in a very controlled framework that includes government policies, price incentive, and consumer demand. And therefore, I think these safeguards by governments and these guidelines by governments need to really frame the investments of the private sector in there. And in particular, at the moment, there's no market for negative emissions. And until that happens, then you can't incentivize a market and investments from the private sector for that. There is a risk, and I'm not denying it. And I think there is a risk if the sustainability guidelines are not strong enough, or if there's no verification afterwards that things are done in ways that are detrimental for other priorities and even that don't work, which would be the sum of two bad things. But there is, in fact, a potential and a need to put these things in place.